Hi, my name is Kasi. My project is design of a MEMS capacitive chemical sensor. The sensor works on the scope of the polymer. The aim of the sensor is to detect volatile organic compounds like octane, benzene, and toluene, and also chemical warfare agent stimulants like dimethylmethylphosphonate, which is EMMP, and CEE. It is a polymer-based sensor built using the MEMS fabrication technology. The need to go with MEMS is to reduce the size and the weight of the sensor. On observing the target chemicals, the polymer in the sensor swells and changes the capacitance of the sensor, which can be detected and measured. The capacitance of the sensor is affected by various factors of this during the fabrication process. The dimension of the sensor measures 450 x 450 micron. The design of the sensor starts with growing a layer of thermal oxide on a 100 silicon wafer. The bottom electrode is made up of titanium, as it can be easily sputtered and etched. They need to select a titanium electrode so that it can withstand all the fabrication processes which comes after it. This titanium electrode can also resist the aluminium etchant, which we will be using while the fabrication of the top electrode. In the sensor, the polymer which is used is PEVA, which means polyethylene vinyl acetate. It is a solid polymer, and during the fabrication process, a solid polymer is more effective than a liquid polymer. The PEVA is spun over the titanium electrode. The deposition of the polymer also needs the solvent, which is the chloroform. The thickness of the polymer layer is maintained about 1 micron, and the sensitivity of the sensor depends upon the thickness of the polymer. So as the thickness increases, the sensitivity decreases. The polymer thickness has an effect on the sensitivity of the sensor. The polymer is patterned with an aluminium hard mask and is etched in a biolasher using O2 and CO4 gases. The aluminium mask is removed by the wet etching process. The top electrode is a layer of aluminium and it's patterned using the photoresist. The top electrode needs to have holes in it so that it can allow the analyte to interact with the polymer, which makes the polymer to swell and change the capacitance of the sensor. And also, when the polymer swells, the top electrode also expands, and for that, to move it along with the polymer, support springs are needed for the top electrode. The base capacitance of this sensor is 1.7 picofarad. The constraint for this sensor is that as we have used only one polymer, it can sense only one chemical at a time. But if in the case of an array of sensors with different polymers, more than one volatile organic compound can be sensed. Another constraint is that as weak bonds are formed on interacting with the analyte, this polymer doesn't come back to equilibrium immediately after swelling. It takes 5 to 10 minutes for it to reach the equilibrium. So these are the two constraints for this sensor which can be overcome when worked on it. These are the references for this sensor design. Thank you.